Awesome. Can you guys see that okay? Great. Yeah, and really quick introduction here, Scott Jade. I work with Constellation Energy, and I manage our R&D portfolio and really look from a generation perspective about 5, 10, maybe sometimes 15 years out, depending on some of these technologies, and really start to challenge some of the assumptions we have as a business, as well as some of the technology areas we focus. And Constellation at large is a generation company. We have 22 nuclear reactors across North America. We have many wind sites, solar, hydro. Um, uh, what else did I not say? There's a lot of other stuff out there too. I should have a slide in here on that next time. Um, and what we're really going to focus on today is really putting some challenges out there and really building on a lot of the hype right now, just in terms of all of this focus on increased load. And for historical kind of analysis here, looking at some of the fundamentals across the power markets, it's been pretty steady load growth. And all of a sudden here, a lot of the headlines are kind of implying that it's directly correlated to data centers as you kind of now look into forward-looking aspect here with some of these scenarios that are kind of being projected out to 2030 and beyond. Even as we think about electrification of buildings, as vehicles, even of homes, it's really creating this dynamic interaction across the grid, which is ultimately having a higher demand for power consumption and ultimately generation. So this is really building up to a lot of these different scenarios are building up to uh, just many different opportunities in market for innovations to happen. And I'm going to kind of present three opportunity areas here today. There's many in between, but really just level setting on where we sit across the business or across the grid. And there's many innovations within these today, but as we present the challenges, kind of the next slide, keep this in mind. So as we say supply, this is thinking about where the power is coming from. So the electrons have to be produced in some ways. So today there's nuclear out there, there's hydro, gas. There's many different nuances within the fossil fuel side, and then within renewables, whether it's wind, solar, geothermal, hydroelectric. There's many other subcategories of that as well. So generation is all kind of clumped into the left side here. As we think about the transmission and distribution, these are the big poles and wires that you see out there, either kind of along highways or in your neighborhood. Many different nuances here as we think about getting the power from the left side to the right side. This, in theory, has to be correlated to the consumption. So as more demand is out there, kind of on the end user on the right side, you have to build poles and wires. I will put in there a caveat. There's is a major assumption. There's a lot of innovations that kind of help to work around this one for one. And then the right side here is kind of the customer end use. And this is where we sit in terms of our homes, in terms of office buildings, universities, and campuses and stuff. So really just kind of providing us as a landscape here for us. So as we think about where we sit in the market, there's three big areas I want to kind of provide as a challenge today. The first one being clean dispatchable power. I'm saying dispatchable because power is going to be needed at many different times across the grid versus where we've come over the last several decades. And this is thinking about whether it is data center related, when it's folks coming home, plugging in their cars, there are these major spikes happening. And this dynamic aspect of the grid, it was not really built to handle this. So having this capability of dispatching this power quickly, hydro, which you're seeing behind us in the picture, this is our Conowingo Dam up in Maryland. It takes about 2 hours for it to ramp up. So we have to either overgenerate or in some cases kind of react to kind of signals happening in the market for those things to happen. As you think about nuclear power, it takes us almost 2 months to turn off nuclear. So that is not going to happen for any of these scenarios. So there's many innovations in this space today that we consider clean dispatchable power, and we as an organization are still focused on carbon-free power, even though some of the policies out there today are not supporting that. So this is and I'm not going to give too many kind of narrowing areas here within this opportunity area. But it's a very important one. There's a lot of capital dollars being put out there, especially as you think about where this power is going to come from. And certain states are also starting to support this. As we think about energy storage, this is another big one in terms of how can you help cushion and subsidize some of these times in the grid when power is needed and when maybe when there's not enough generation. I'm saying energy storage here instead of batteries because energy storage can happen in many different ways. It doesn't have to be a chemical. It doesn't have to be a lithium-ion battery like we have in our phones and our computers. So as we think about even this hydroelectric dam here, further up the river, we have a pump storage system, and this is just using water as a battery, essentially. We're pumping water up into a higher elevation area when we have excess power, and then when we need that power, we bring it down and push it back through a turbine. So there's many different other innovations in this space, storing it underground, as well as other thermal and physical solutions out there. The last one we're going to kind of present here is the balancing of the generation and the load side. So this is thinking about kind of the two sides of that spectrum I showed in that graphic. There's a lot of orchestration that can be happening here in this space. There's a lot of challenges in the market today in terms of why some of this is not occurring. But there still is a huge gap here in terms of some of these innovations. There's a lot of concepts out there considered virtual power plants, demand response. There's a lot of other buzzwords in this area, but ultimately starting to think about as generation load is higher demand, how do you kind of create that dynamic grid to help handle that, or vice versa? What if all of a sudden the grid can't handle it? How do you throttle down some of those loads? So there's a lot of programming opportunities around this area as well. So at large, these are kind of the three areas I'm kind of punting out there today. There's obviously many more, but I think these are kind of core, some three big areas for us to kind of go into. I'll pause there. I don't know if we want to see if there's any questions. I have a few examples of some other innovations that we're doing if there is time, but I'll pause there for questions.
Feel free to throw anything in the chat too, if anyone has any questions.
It's got one question. When you say clean dispatchable power, like what kind of turnaround when you see that spike? Like what is the dream turnaround that power is generated from?
So,
5 minutes, 10 minutes?
yeah, Mike. There's a lot of nuances to this, and for doing that matchmaking today, essentially what we do in the grid is we actually overproduce to make sure we never actually exceed the generation curve there. If that does happen, that's when a brownout occurs. So you always need to make sure you have a certain buffer of generation over what that actual load signal is, that actual load on the grid. Um, Gas plants today and peaker plants helps to reduce that buffer so we don't always have to overproduce nuclear or hydro or any other fuel. Those peaker plants can turn on within about 30 seconds. Those are very quick to dispatch. And dispatch means we're getting a signal that, hey, there's more demand. Hey, go turn that on. Some of these plants are actually remotely operated. There's no physical human there, and they can be turned off and on remotely. Um, so there's a lot of nuances, things like the hydro, it takes a little bit of time for it to kind of get going. Um, and wind, there's a lot of other nuances where it's like, hey, actually, is that ridge line out in Western Maryland or Pennsylvania receiving wind right now? And then is it worth turning that on, or do we turn another power plant on? So there's a lot of optimization happens. Our trade floor is actually in Baltimore there. We have some very innovative AI tools right now that we're deploying across our fleet to look at optimizing based on cost as well as based on kind of regionality. So as you think about hydro, we don't want to put all that water down the stream all at once. We want to make sure we have that in reserve over time based on other weather patterns coming down the coming month or so. So it's a lot of nuances to how this is operated.
Go, James, do you have a question as well?
Yes, can you hear me?
Yes.
Yep.
Scott, I have a question. Is your utility interested in reducing its carbon footprint? We have a process that helps put underutilized utility lands to work capturing CO2 and sequestering the captured carbon in a very cost-effective way.
Yeah, no, we still have a net zero goal. We're actually one of the biggest carbon-free producers in the U.S. since we have so much nuclear. We only have two gas plants right now, and the diesel generators at our nuclear sites are actually the dirtiest products that we have there, and that's just for emergency uses. So we do have a carbon trading desk internally. We create carbon credits through a few other projects and mechanisms today. We actually sell them to customers and stack them on top of power attributes as they consume them. We have worked with two other entities in the state to look at creating carbon credits within maybe not our right of ways, but some of the Exelon right of ways across the state. So it is an area of interest for us. We're interested in insetting some of those offsets to help offset some of our current greenhouse gas emissions, but also how do we help provide this as an opportunity for customers? So to your question, yes, we're interested. We have a few things in the pipeline as well.
Can you put your contact information in the chat so I could communicate with you?
Of course, yes.
Thank you.
Jeremy, I think this will be the last question.
Thank you. Great presentation, Scott. My question, is there a role for immersive technology or digital twins, like to help planners simulate grid stress scenarios or like energy storage use cases? Like, what's your attitude towards that?
Yeah, Jeremy, great question. And this is where we're in a very unique position to market versus some of the other utilities who have a much smaller focus. And we don't yet have a digital twin created of um, our macro assets. So thinking about how all of our assets kind of work together. We do have one scenario where I think a digital twin could be a great application for this Conowingo Dam application to Maryland, where we have Conowingo, Muddy Run, which is that pump storage facility, and then we have Peach Bottom Nuclear Plant, all within 3 miles of each other. So we're now having to think about what are the implications of the weather, what are the implications of the regional grid, and then we always have to worry about the environmental uh, constraints of kind of the Susquehanna River there. So just thinking about from an operational standpoint, hey, when do we dispatch some of this power? When do we produce it? Do we need to ramp down nuclear because there's going to be a whole lot of water coming down this path? So just thinking about how that operates and doing some what we do today is scenario planning, and that's very defined in terms of saying like, hey, here's 10 variables we're going to change. Versus Jeremy, to your point, digital twins, you can almost work out these kinks and opportunities in near real time. So it is a major opportunity across the whole industry, I think, as we then look into getting more years out of these assets. Hey, what if we increase the temperature of that gas turbine? What is the life cycle impact of that over the life of that generation versus something else? So I love that concept. It is being talked a lot about in the industry, um, but I think it's a great direction to go.
Thank you. Scott, did you have more to cover?
Let me just put up one more slide just as like a fun use case. Let me see if I can actually do this. There we go. So this is thinking about just an application of AI, and AI today is being talked about everywhere, but this is one that we're actually seeing core saving benefits of. And this is thinking about in the nuclear side. When we do outages and we actually swap nuclear fuel rods within the reactor itself, there's a set standard that the Federal Nuclear Regulatory Commission kind of gives us. And this was a challenge that we gave ourselves about 2 years ago, working with MIT to actually develop uh, a different scenario using AI. And instead of doing that traditional kind of methodology for swapping those fuel rods out, we're now using the actual status of the fuel rods themselves, putting them back into a simulator and then repurposing these fuel rods in the future. So we're getting a cost saving across our whole fleet of almost, I think, $62 million right now, annually, with this. And this is also thinking about we have to find alternative ways for uranium, with some of our um, sites, just given the Russia constraints right now. So just thinking about where innovations can sit across the power industry, there's a lot of opportunity here. This is actually a company now that is spinning out of MIT and going to market. So there's a lot of opportunities here just to look at, hey, what are problems that the industry is facing? This is obviously a much bigger benefit for us as a business, let alone kind of across the whole market, and kind of really building on a real world geopolitical constraint right now. So just pulling on the AI, some of the geopolitical components, as well as kind of some of the core problems as a business we're having. So I will leave it there. I will put my contact information in the chat, and feel free to reach out if you guys have any questions.
That was great, Scott. So we're gonna move on. And Brad from Green Gen is going to present.
Hey, thanks, Mike. So I'm going to just spend just a couple minutes talking about sort of, from my point of view, what do buildings need? What do they want? What are the opportunities that you can potentially develop? And if you go to just the next slide, just to give you a quick sense of sort of the perspective I'm coming from. Next one. So, my background before starting GreenGen was really was on the real estate investment side. I came out of real estate private equity. I started at JMB, which at the time was the largest real estate firm in the country. I spent a decade at Starwood Capital, one of the leading global opportunity funds, founding their business in both Asia and Europe. And then finally running the East Coast for CalPERS, State of California Public Employee Retirement Fund, pension fund backed firm doing development, particularly in DC and New York. I also sit as a global governing trustee of ULI, the Urban Land Institute, which is the leading organization focused on the built environment, and sit on ULI's Sustainability Center board globally. And so I have a very interesting perspective. It's not just about sustainability or decarb, but it's really how can you do that profitably? And at the end of the day, your idea has to be profitable. It has to drive ROI. There has to be an ROI for every dollar that you're looking or asking someone to give you. And if you do that, there'll be lots of interest. If you don't, there'll be less. Go to the next slide real quick. The work we're doing around the world is for about 2/3 of our businesses leading global investors. So just to give you a sense, it's Blackstone, it's KKR, it's Starwood, it's Brookfield, it's Macquarie, it's the leading global firms. These firms, gently put, are very greedy. I don't say that in a mean way, but the point is, everything we're doing around sustainability or decarb or net zero has to be profitable. And if it's profitable, there's a lot of interest from our investors and our clients. If there's not, they're out. They're not going to work with us. They're not going to do anything. And so it's critical to have that business case. Well, let's go to the next slide, please. So let me start with sort of two questions I think you should be asking. The first is, what do buildings need? First and foremost, they want to see their expenses reduced. In a time where real estate broadly has demand challenges, lower occupancy, pressure on rents, whether it's coming from the economy, whether it's coming from the federal government, basically wanting to take less space. The first and easiest way to drive ROI is to reduce expenses. And the key expenses are electricity, which is generally the largest. It is water. Increasingly, water on a percentage basis is going to increase more than any other commodity. Why? Because we've underinvested in CapEx. We haven't kept pace with all the infrastructure that delivers water to you. And finally, in the last couple of years, we've increasingly seen insurance as a really interesting category of spend. We used to talk a lot about, the cost of insurance. Increasingly, the question is not the price of insurance per se, but it's the availability of insurance at all. Whether it's Los Angeles, whether it's Florida, um, various physical climate risks and climate events are putting tremendous pressure on the insurance industry. And we're seeing, prices and costs of insurance go up. And it becomes a really interesting lever of potential ROI depending on sort of what we're doing. And I'll give you an example of that at the end. But also less transitional risk. When we talk about transitional risk, we're really talking about regulation. More than 50 municipalities around the country today have some form of regulation. Typically, it comes with some sort of expense or climate tax or carbon tax. In the Washington area, you have it in DC, you have it in Maryland, you have it in Montgomery County, you have it in Arlington, Fairfax. We live in an area with tremendous pressure and basically sticks, if you will, but also New York, Boston, Chicago, Denver, all manner of different areas have it. And the pressure is actually much higher today than it has been a couple of years ago. As the federal government has come back and applied less pressure on the built environment or gone backwards, we're seeing every other stakeholder, particularly cities and states in the US, countries outside the US, equity investors, debt investors, occupiers, their employees, their customers, their supply chain, all basically push more, push faster, in a much more onerous state. Transition risk is very high. And in some cases, like New York, you're seeing buildings that have potential for more than $1 million a year of carbon tax or some other type of penalty. And depending on the amount of it, that could be upwards of $20 million of equity. It is an enormous piece of pressure, but it's also an enormous opportunity if you can find ways to address it and mitigate it. Low carbon materials, embodied carbon, that's concrete, that is steel, but it's also a myriad of other things. It's different technologies. It's, cross-laminated timber using wood as opposed to concrete and steel. It's also smaller staff. What I mean by that is, can you provide or identify technology that reduces the need for people? An office building perhaps 10 years ago would have had 10 people working on it, engineers and staff. Today, that same building might have 2.5 people. The pressure on headcount has been significant. And these are all teams now that have less time to be doing more. And so if we can find ways to have technology replicate best practices or people and to do things more efficiently, that's a really important thing. And that, to the next point, is a pain point. What are the staffs doing, whether it's a property manager, engineer, asset manager, owner? What are the things that they're doing that they don't want to do or take up a lot of time? And can we identify or create a technology to do it better? There are all manner of things like that. It's sensors, it's controls, it's software overlays that basically look at weather data to basically help Scott and his utility predict, do a better job. So when they have a demand event where they have to have fast dispatchable power, there's less pressure, and they will pay you for reducing the energy that you're using in a building. And then better technology. Better technology is essentially either a cheaper technology, so it's doing the same thing but at a lower cost, or at the cost it was before, it is more powerful. So there's a greater return on each dollar. Each of those, both of those are really valuable to people and building owners. And so let's go to the next slide. And so the question you should be asking is, what's your big idea? And there's different ways to think about that. It could be technology. It could be a better sensor. It could be a better light, but it also could be a better business model. The reality is today, we're not really inventing brand new types of solar. The big innovations in solar, for example, is the business model. How does the solar get on your roof? How do you identify the opportunity? How do you finance it? How do you put it on the roof? How does you make that process efficient? The same too on financing energy efficiency. CPACE is a good example of that. They're not upgrading your building. They're finding a better business model to deliver the savings and the improvement on design to your building. And then, key things I think are who buys it? Who actually needs your technology? Is it the building owner? Is it an integrator? Is it a sensor that goes into something else? How do they buy? Are they buying the hardware? Are they basically, buying the software as a service, energy as a service? What's the different way to buy it? Is it they put up the money? Do you finance it? Do you put up all the money and they pay you a service fee? And then finally, what I was saying before, the business case. It is critical for you to think about the ROI. When we talk to clients, we don't basically recommend or advocate them putting up $1 without giving them really explicit ROI for that. We have to help them understand how it is in their interest, whether it drives the value of the asset, or the other big thing in our world is helping people access capital more efficiently, raise money faster on the equity side or on the debt side, better terms, higher proceeds. Let's go to the next slide. The challenges that you will face, and this is 15 years of doing this, so this gives you an advantage and a leg up. Who do you compete with? As whether we're using a technology or whether we're investing in technology, I will tell you that we've never had a company that has done a good job of thinking about who they compete with. Time and time again, we hear companies say, we're the only one that does this. And my reaction is, you're not just the only one who, you're not the only one who does. In fact, you're not the only one within, your block. I know one other company that's around the corner from you doing it. I know 10 other companies in Washington, D.C. that are trying to solve for the same thing. So, be honest with yourself, and understand the competitive landscape. What are you doing? Why is it better than other people? How do you acquire customers? It's really important to understand who your customers are and how are they actually going to buy it. How do you get to them? Whether it's direct mail, whether you have to know them, what does that sale look like? How does someone buy your thing? What's the business model? What's the business case for it? And probably really, really important that people often forget about is how do you actually demonstrate ROI? It's one thing to say this will save you money, but where's the data set for that? Where's actually the business case that demonstrates that? There are some things, for instance, reducing electricity, that are pretty easy. There are other things that are, I think ROI is frankly a more nuanced problem to be solved. And you have to really, think about what are the right KPIs and how do you actually get that data, both the baselining, where were you before the intervention or your technology, and then how do you actually, once you've done your work, how do you actually demonstrate that ROI? Let's go to the next slide. So let me just very briefly give you an example. Conservation Labs is a company that we work with that we've also invested in. It comes out of Carnegie Mellon. It is based in Pittsburgh. Their big insight was that water leaks insurance costs more than 80 billion US dollars a year. It's pretty boring. It doesn't hit the papers. It's not something people think about, and yet it's an $80 billion a year issue to the built environment. Conservation Lab said there's got to be a better way to both think about identifying that there's a water leak, but also the cost of the event itself. And their innovation was essentially to put an acoustic sensor to listen to the water pipe and water infrastructure, listen for a water leak. There is a very clear acoustic pattern to a water leak. And they basically found a cost-effective way and very quick to install to put the acoustic sensor on the pipe and then have the ability to have that device link into a valve, if you want, on the actual pump or water infrastructure so it can cut it off. This is a pain point. This is about thinking about people. if you had people that could sit in your building 24 hours a day all over the place, they could listen to this. They could look for the water leaks, but there's a better way to do it, to use the acoustic sensor cost effectively to do it, and then link it into the cost of the event by shutting down the valve really quickly. Great insight. Insurance companies are paying for it. Multifamily is paying for it. Hotels are paying for it. And at the end of the day, let's go to the last slide, please. At the end of the day, we know that these innovations are able to drive both a financial outcome with a sustainability outcome at the same time. This is what we do in our business. This is what it means to operate in the green, have both a profitable intervention that is also driving a sustainability or climate outcome.
That's awesome, Brad. Thanks for that. I would have never thought water leaks, how much money that could save by just being able to recognize it. And the last challenge, we'll have Sarah talk about of the circular economy and opportunities for recycling. Take it away, Sarah.
All right, thank you. Emily, are you advancing slides or am I? Oh, wow, look at that. So slick. Okay, hi everyone. My name is Sarah Morley, and I'm the Strategic Engagement Manager for Circular Economies at WRAP. And today we're going to talk about how to innovate for the circular economy. We can go on to the next one. And just a little bit about me, aside from my work at WRAP, I'm also the author of We See Wednesdays, which is a weekly zero waste newsletter, although recently it's been every other week. I have a few certifications in zero waste planning for businesses and communities, and I got a couple of master's degrees at Johns Hopkins University, where I studied public and private opportunities to lowering greenhouse gas emissions through our waste system. And all of that is to say that I love talking about trash. We can go to the next slide. And so today we're going to quickly cover the difference between the linear and circular economies, and then talk about societal changes and business opportunities related to food and textile waste. So the economy that we're in right now is mostly linear. You take resources from the earth, you make a product, you sell it, and the consumer uses it, and then they toss it in the trash when they're done. And according to the National Renewable Energy Lab, the amount of plastic that we landfill every year is worth $7.2 billion if we were to keep it in circulation. And for those of you who care about reducing greenhouse gas emissions, which I think this audience does, 45% of global GHGs come from resource extraction and consumption alone. So the linear economy generates nearly half of our greenhouse gases, and then it dumps money in the trash. So moving forward to the next slide, that is why today we're talking about the circular economy. There's billions of dollars worth of commodities that go into the trash that could be kept in circulation. So here we have an image that I grabbed from FESPA, and it gives you an idea of what this looks like. Because, oftentimes you hear like circular economy, you think like, okay, but like what does that mean? So you see at the start, raw material is inputted into the system. It's inputted into the circle. And so it's extracted once. And now this is important. In the design phase, products are designed for the circular economy. So they're designed for easy repair, reuse, and then also simple recycling. So that means it doesn't mean to just create a film plastic that claims to be recyclable. It actually needs to be recyclable for the majority of consumers, right? Like we all know film plastic, you can't put it in your curbside recycling bin. So if you look at the circular economy, it's really just about keeping things in the economy. So it doesn't end up in the trash. It keeps things in circulation. So we can go to the next slide. And before we get into the challenges, I do want to touch on the zero waste hierarchy because this does inform how to work within the circular economy. So often the first thing that comes to mind with circularity is to innovate only for recycling. And I totally get that because this helps us move from a resource extractive process to a circular method. But recycling is near the bottom of the triangle because it's the last effort to recapture materials. You're relying on a number of factors that need to go right in order for it to work. You need the product to end up in a city that has a strong recycling infrastructure. You need population density to ensure a strong and consistent feedstock. You need public education around the activity. And you need a regional market that's actually going to buy the secondhand commodities. And then you're also relying on the customer's altruism to put the product in the right bin, whether that's a household consumer or if it's a business consumer. And then there's the destructive process of recycling, which requires some resources like energy and water, which again, like that's better than extracting virgin materials, but you do have to keep in mind that it does use resources. So that's why you see recycling as tier 4 in the zero waste hierarchy. So at the top, like we mentioned in the previous slide, is redesign. And then the next tier is reduce and then reuse. And so this means reducing the volume of product that you're producing. So instead of selling rice in a plastic bag, you can sell a reusable container once and then sell rice in bulk that go into reusable packaging. And of course, that package can be designed to be recycled eventually, but the idea is to not create like a one and done product, right? So it can be kept in circulation for longer. So maybe it's a glass container or something that can be used until it basically falls apart. Next slide, please. Okay, so now their brain is surging with excitement about innovating for the circular economy. Let's talk about some opportunities in food and textile waste. So starting with food, organic waste that ends up in a landfill produces methane. And consequently, landfills are the second largest producer of methane in the US, which means if you were to divert 75% of organic waste from landfills, that's the equivalent of removing 50 million cars from the road. So if you're someone who's like, man, I really can't buy an electric vehicle right now, like an alternative is you could just eat your leftovers in the refrigerator. Or have like, smarter shopping habits at the grocery store. So food waste creates methane. It's also just like a wasted meal. So according to Feeding America, we could have fed families 145 billion meals with our wasted food. And 35% of our wasted food happens at the household level. So that just means like people purchase too much, it ends up in the refrigerator, they forget about it, it gets moldy and they toss it. It's a number of factors. So it creates methane. We've got a lot of wasted meals, and then it's also a waste of resources. So when you think about like resource extraction, agriculture is a hugely resource extractive process. So if you think about it, 22% of America's fresh water is actually used on food that's never eaten or goes to use. So this is food that just ends up in a landfill. 16% of our cropland is actually used for crops that go to waste. And then 6% of our greenhouse gas emissions come from the production and transportation of food that just goes to waste. Next slide, please. The good news is there's tons of opportunity. 31% of food that's produced in the US is surplus. So that means that's unsold or uneaten. And a tiny, tiny fraction of that is composted or recovered to feed people in need. So that means that there's a lot of money in the value of like the food that's just surplus, right? So it's worth $382 billion a year. That's just money that's ending up in the trash every year that you can innovate a solution for this food. That's 237 million tons of food, and over 40% of it is fresh fruits and vegetables. So it's a lot of perishable items, and 20% of that food is prepared foods. So when you're thinking about this for the competition, you can think about innovations for like how to maybe keep it from decomposing faster, or maybe ways that you can, prepare the food differently so that it doesn't go to waste, or ways that you can feed families or, divert it from the landfill. There's just like so much food, there's so much opportunity, and the majority of this food is edible. And if it's not edible for human consumption, maybe it's edible for agricultural uses, for like chickens or cattle. Not to give you too many ideas, but there's so much opportunity. So for more data on this, I recommend going to refed.org. They have a lot of data that's really useful. So we're going to go to the next slide and we're going to talk about textiles. So this is the next opportunity for innovation and waste. The fashion industry used to have 4 seasons a year. So it was, spring, summer, fall, the typical seasons. But now they have 50 seasons a year. So it's a system designed to churn out new trends so that customers feel like they're always out of style. But it's created this way so that manufacturers or fashion producers can sell more products, right? And they're able to do this because they create clothes that are made of cheap materials and they're also not built for durability. So they save a lot of money and they're also sold at really low prices. So it makes this clothing really accessible to the consumer. The problem with that is that people are buying clothes at a faster rate, and then they're also discarding them at a faster rate. So there's a higher rate of clothing being produced, sold, and purchased, and then landfilled within a 12-month cycle. So consequently, we have 17 million tons of textile waste that ends up in landfills every year. And that's just in the United States. And only 15% of our textile waste, so this is post-consumer textile waste, is actually recirculated through donation sites or downcycled into commercial rags. There's another problem with clothing, and that is bracketing. So consumers are using their homes as fitting rooms, which means they're buying 2 sizes of every style online, and then they try it on at home, they figure out what they like, and then they ship back whatever doesn't work out for them. And so the problem with that is stores are producing twice as many garments because they don't know how much they're actually going to sell, and they have to overproduce. And then they get all these returned items, but because their trends move so quickly, by the time their clothes get returned to them, they're out of style or it's not cost effective to actually re-inventory them and trying to resell them. On top of that, 16 million tons of carbon dioxide is emitted from return transportation alone. And 5 billion pounds of clothes are returned annually, just to put that into perspective. So just thinking about this competition, maybe you can come up with an idea for how to help consumers be smarter about their purchasing decisions online so that they're not purchasing clothes just kind of haphazardly with the assumption that they can just return whatever they want. And then on top of that, clothing, the production of clothing is a huge waste of resources. So it uses 342 million barrels of oil to make synthetic fibers every year. And then the fashion industry also uses 20 trillion liters of water every year. So they're the second largest consumer and polluter of water in the world. We're going to go to the next slide. And then just to wrap this up, some opportunities in textile waste. With the tariffs on China, and a lot of our clothes are produced in China, tariffs on China don't impact our secondhand market. So there is a lot of opportunity for innovation with upcycling opportunities. And there is an abundance of unused goods with tags from people returning items that go unsold. And there may be a resurgence of a market for clothing and shoe repair. And then there's also opportunity to develop technology or systems to improve clothing fits and then reduce returns. And that's all I have. But thank you for your time.
Thank you, Sarah. It was great. We don't have much time left.
I know. Sorry about it.
The Mike or Emily, yes. Do we want to walk through kind of the last pieces here?
Yeah, so just kind of last piece we can add is we're going to bring in some of our awesome MEIA startups to help mentor and facilitate the innovations on Saturday, May 3rd. So Patrick, who is or potentially was on the call, will be joining us with Forager Station. Kabiose Kuzi, who's the founder of Pearl, and then Betty Watson, who's the founder of Venki Energy. So those are three exciting startups that will be joining us and kind of sharing a little bit about their journey and helping share more about the innovation. And then just last piece, since I know we're a little over time, where screen is frozen. There we go. But so next step is we'll be just asking you to fill out a quick form of which innovation and which challenge is most exciting to you. This will help us kind of make teams and help facilitate that. So we'll be sending around this form, or you can go ahead and scan the QR code on the screen and we'll track your submissions. If you have ideas, you can share the name of your idea or just select which challenge you're most interested in. And then we'll be making teams first thing in the morning on Saturday, May 3rd, and then hacking for the future. But thank you everyone for joining today, and hopefully we're excited about some of these challenges and brainstorming innovations.
Yeah, and big thank you to Brad, Scott, and Sarah for joining and sharing their challenges. They've all shared their contact information in the chat for those of you that are interested as well. So thank you again to everyone for joining, and thank you especially to our speakers here and sponsors. So thanks everyone. Bye.